Hello everyone, I Vikas Kachapadel from Param Guru Pathshala English Medium School, Sarsa. Standard 12 Science, Subject Mathematics, Unit Number 1, Relation and Function. Today I will start exercise 1.1, question number 3, 4, 5, 9, 12, 13. Okay. The next question number 3. Check whether the relation R defined in the set A 1, 2, 3, 4, 5, 6 as R is equal to order pair AB, where B is equal to A plus 1 is reflexive, symmetric or transitive. Here check reflexive, symmetric and transitive relation. So that set, given set A is equal to 1, 2, 3, 4, 5, 6. A relation R is defined on set A as R is equal to order pair AB, B is equal to A plus 1. Okay. Here, so then R is equal to, let A is equal to 1, so then B is equal to 1 plus 2, and A is equal to 2, so then B is equal to 2 plus 1, then 3. Okay, so then next A is equal to 3, so then B is equal to 3 plus 1, 4. So similarly 4, 5 and 5, 6. So therefore relation R is equal to order pair. Okay, 1, 2, 2, 3, 3, 4, 4, 5 and 5, 6. So we can find first check reflexive property. The reflexive property means for every A belongs to set A implies order pair AA belongs to R. But here AA does not belongs to R because 1 1 does not belongs to R, 2 2 does not belongs to R, 3 3 does not belongs to R. Okay, so therefore R is not reflexive relation. Okay, R is not reflexive relation. Next, here 1 2 belongs to R. Okay, here 1 2 belongs to R, but 2 1 does not belongs to R. So therefore R is not transitive relation. Sorry, R is not symmetric relation. Okay. Next, now 1 2 belongs to R and 2 3 belongs to R, but 1 3 does not belongs to R. Therefore R is not transitive relation. Okay, the hence R is neither reflexive nor symmetric nor transitive relation. Okay. Next, question number 4. Show that the relation R in set R defined as R is equal to order pair AB, where A less than equal to B is reflexive and transitive but not symmetric. Okay, so here set set R means real number set. Okay, here relation R is equal to order pair AB, where A less than equal to B on set capital R. Okay, means real number set. Okay, so here first of all check reflexive property. So clearly every A belongs to R because A is equal to A. So therefore A is reflexive relation. Okay. Next, AB belongs to R. Okay, so implies BA belongs to R, but here 2 4 belongs to R. 2 4 belongs to R. That means 2 less than 4. Okay, but 4 2 does not belongs to R because 4 is greater than 2. 4 is greater than 2. So therefore 4 2 does not belongs to R. So therefore R is not symmetric relation. Next, now let AB belongs to R and BC belongs to R. Okay, AB belongs to R and BC belongs to R. So then A less than equal to B and B less than equal to C. So therefore A less than equal to B and B less than equal to C. So that means A less than equal to B, B less than equal to C. So therefore A less than equal to C. Okay. So therefore AC belongs to R. So therefore R is transitive relation. Okay, hence R is reflexive and transitive but not symmetric relation. Okay. Next, question number 5. Check whether the relation R in a set R defined as R is equal to order pair AB, where A less than equal to B cube is reflexive, symmetric or transitive relation. Okay. Let here set relation, okay, R is equal to order pair AB where A less than equal to B Q, okay. So it is observed that 1 2 1 2 does not belongs to R because 1 2 greater than 1 by 2 whole cube, okay. So 1 by 2 whole cube, that means 1 by 8. So therefore 1 by 2 greater than 1 by 2, okay. 1 by 2 greater than 1 by 2, therefore R is not reflexive relation, okay. Next, now 1 2 belongs to R, okay. 1 2 belongs to R. 1 less than 2 cube, okay. The 1 less than 2 cube means 1 less than 8, but 2 1 does not belongs to R because 2 cube greater than 1, okay. 2 cube greater than 1 means 2 cube greater than 1 means 8 greater than 1, so therefore R is not symmetric relation. We have order pair 3 3 by 2 3 by 2 6 by 5 belongs to R, okay. Here 3 3 by 2 belongs to R, that means 3 less than 3 by 2 square, okay. 3 3 by 2 less, sorry, cube, okay. And 3 by 2 6 by 5 belongs to R, that means 3 by 2 less than 6 by 5 whole cube, okay. But 3 6 by 5 does not belongs to R because 3 greater than 6 by 5 whole cube, okay. 3 greater than 6 by 5 whole cube, so therefore R is not transitive relation. So hence R is neither reflexive nor symmetric nor transitive relation, okay. Next, question number 9. Show that each of the relation R in the set A is equal to x belongs to capital Z, where 0 less than equal to x less than equal to 10, given by first R is equal to order pair AB, where A minus B is a multiple of 4. Here given relation R is equal to AB, modulo of A minus B is a multiple of 4. Is an equivalent relation, okay. The first of all check equivalent relation, and next find the set of all elements related to 1 in each case, okay. So first of all check equivalent relation. What is equivalent relation? So R is equivalent relation. So if R is reflexive, symmetric and transitive relation, here relation R is equal to order pair AB where modulo A minus B is a multiple of 4, okay. But here given set A is equal to x belongs to Z, 0 less than equal to x less than equal to 12, that means A is equal to 0 1 2 3 4 5 6 7 up to so on 12, okay. For first of all check reflexive property for any A belongs to capital A, okay. So therefore where A belongs to R because modulo of A minus A is equal to 0. So always 0 is a multiple of 4. So therefore R is reflexive relation, okay. Now let AB belongs to R. AB belongs to R, that means modulo A minus B is a multiple of 4, okay. The minus common, the modulo of minus B minus A is a multiple of 4. So that means modulo B minus is a multiple of 4. So that means BA belongs to R. So therefore R is symmetric relation, okay. So R is symmetric relation. Next, AB belongs to R and BC belongs to R. Here given AB belongs to R, BC belongs to R. That means A minus B is a multiple of 4 and B minus C is a multiple of 4. Okay. So implies here A minus B is a multiple of 4 and B minus C is a multiple of 4. So then always addition is a multiple of 4. So therefore a minus B plus B minus C is equal to, plus minus B cancel out, so is equal to A minus C is a multiple of 4. So implies modulo of A minus C is a multiple of 4. So implies AC belongs to R. So therefore R is transitive relation. So hence R is an equivalent relation. Okay. The next question, find the set of all element related to 1 in each case. Okay, તો find આપણે સેટ કરવાનો છે કે જે related to 1 means number છે. Okay, તો first check કરીએ તો the set of element related to 1 is 159. Why 159? So first of all check the 4 modulo 4 minus 1. Okay, sorry, first 1 minus 1. So 1 minus 1 is equal to 0. So 0 always multiple of 4. Okay, next modulo of 5 minus 1. The modulo of 5 minus 1 is equal to 4. So 4 is multiple of 4. Okay, next 9 minus 1. So 9 minus 1 is equal to 8. So 8 is a multiple of 4 because 8 is equal to 2 into 4. Okay, so the set of element related to 1 is 159. Suppose here set of element related to 2. Suppose 2 number આપણને કહે તો what is set? So set of related to 2 is 2, 6 and 10. Okay, because 2 minus 2, so 2 minus 2 0, so 0 is multiple of 4. Next 6, 6 minus 2, 6 minus 2 is a 4. Okay, so 4 is a multiple of 4. Next 10, 10 minus 2, 10 minus 2 is equal to 8. Okay, so 8 is a multiple of 4. Okay, next question number 9. Show that each of the relation R in the set A is equal to X belongs to Z. Okay, 0 less than equal to X less than equal to 12 is given by R is equal to order pair AB, where A is equal to B is an equivalent relation. Find the set of all elements related to 1 in each case. Okay, here previous question only relation change. Okay, here relation R is equal to order pair AB, where A is equal to B. Okay, here set A is equal to 0, 1, 2, 3, 4 up to so on 12. Okay, and given relation R is equal to order pair AB, where A is equal to B. Okay, so first of all reflexive property check. So since AA belongs to R, okay, AA belongs to R because A is equal to A, always true. So therefore R is reflexive relation. Okay, R is reflexive relation. Next, let AB belongs to R. Okay, so AB belongs to R, so implies BA belongs to R. Okay, AB belongs to R, so is equal to A is equal to B, so implies B is equal to A, so implies BA belongs to R. Okay, BA belongs to R, so therefore R is symmetric relation. Next, transitive relation. So let AB belongs to R and BC belongs to R. Okay, let AB belongs to R and BC belongs to R. So implies A is equal to B and B is equal to C. Okay, here AB belongs to R, that means A is equal to B, and BC belongs to R, that means B is equal to C. So implies A is equal to B is equal to C. So implies A is equal to C. So implies AC belongs to R. Therefore R is transitive relation. Okay, means R is in equivalence relation. Okay, because R is reflexive, symmetric and transitive relation. Next, find the set of all element related to 1 each case. Okay, so here only 1 is equal to 1 possible. Okay, so element in R that are related to 1 will be those elements from set A which are equal to 1. Hence the set of element related to 1 is only 1. Okay, next question number 12. So that the relation R defined in the set A of all triangle. Here given set A all triangle as R is equal to order pair T1 T2, where T1 is similar to T2 is equivalent relation. Consider three right triangle T1 with side 3, 4, 5, triangle T2 with side 5, 12, 13 and triangle T3 with sides 6, 8, 10. Which triangle among T1, T2 and T3 are related? Okay. So first of all check equivalent relation. Okay, so given relation R is equal to order pair T1 T2 where T1 is similar to T2. Here given set A means all triangle. Okay, so since every triangle is similar to itself, okay, so therefore R is reflexive relation. Further, if T1 T2 belongs to R, okay, T1 T2 belongs to R, that means T1 is similar to T2, so implies T2 is similar to T1, so implies T1 belongs to R, so therefore R is symmetric relation. R is symmetric relation. Let T1 T2 belongs to R and T2 T3 belongs to R. Okay, let T1 T2 belongs to R and T2 T3 belongs to R. So that implies T1 is similar to T2 and T2 is similar to T3. It implies T1 is similar to T3. It implies T1 T3 belongs to R. So therefore R is transitive relation. So therefore R is reflexive, symmetric and transitive relation. So therefore R is an equivalent relation. Okay. Next consider three triangles. First triangle T1 with side 3, 4, 5. Second triangle T2 with side 5, 12, 13. And third triangle T3 with side 6, 8, 10. So which triangle among T1, T2 and T3 are related? Okay. Which triangle T1, T2 and T3 are related? So first check करें. So now we can observe that the corresponding side of triangle T1 and T3 are in the same ratio. Okay. Why same ratio? So first triangle T1. So T1 first triangle T1. So which side 3, 4 and 5 on third triangle T2 with sides 6, 8, 10. So 3 to the 6, 4 to the 8 and 5 to the 10. Okay. So what is ratio? The ratio triangle T1 is similar to T3. So his T1 is related to T2 with ratio of 1 by 2. Okay. Next question number 14. Let L be the set of all lines in xy plane. Okay, and R be the relation in L defined as R is equal to order pair L1 L2 where L1 is parallel to L2 so that R is an equivalent relation. Find the set of all lines related to the line y is equal to 2x plus 4. Okay, so first check here given relation R is equal to order pair L1 L2 where L1 is parallel to line L2. Okay, so any line L1 is parallel to itself L1. Okay, the L1 is parallel L1, so that means L1 L1 belongs to R, so therefore R is reflexive relation. Okay, R is reflexive relation. Next L1 L2 belongs to R. L1 L2 belongs to R. That means L1 is parallel to L2. It implies L2 is always parallel to L2. Okay, so L1 L2 is parallel to L1. So implies L2 L1 belongs to R. So therefore R is symmetric relation. Next transitive relation. Let L1 L2 belongs to R and L2 L3 belongs to R. That means L1 is parallel to L2 and L2 parallel to L3. Okay, so implies L1 is parallel to L3. Okay, so therefore R is transitive relation. Why R is transitive relation? So L1 is parallel to L2, so always L2 parallel L3, so therefore L1 is parallel to L3. Okay, so hence R is an equivalent relation. The set of all lines related to the line y is equal to 2x per 4 is the set of all lines that are parallel to the line y is equal to 2x plus 4. So always parallel line always slope same. So your slope of line y is equal to 2x plus 4 is m is equal to 2. So it is not a parallel line. So we have the same slope. Okay. The line parallel to the given line is of the form y is equal to mx plus c. Okay, parallel line form कयो हशे y is equal to mx plus c because but m is equal to 2 slope of line okay so y is equal to 2x plus c where c belongs to r. In the set of all lines related to the given line is given by y is equal to 2x plus c. Okay. Next question number 15. Let R be the relation in the set A is equal to 1, 2, 3, 4. Given by relation is equal to order pair 1, 2, 2, 2, 1, 1, 4, 4, 1, 3, 3, 3 and 3, 2. Okay. Choose the correct answer. First, R is reflexive and symmetric but not transitive. B. R is reflexive and transitive but not symmetric. C. R is symmetric and transitive but not reflexive. And option D. R is an equivalent relation. Okay. So first of all, here given relation R is equal to order pair 1 2 2 2 1 1 4 4 1 3 3 3 and 3 2. Okay. So first of all here set A is equal to 1 2 3 4. So first of all check reflexive property. So reflexive property for every A belongs to capital A. So A is equal to 1. The first pair 1 1 belongs to R. Yes. Next A is equal to 2. So 2 2 belongs to R. Yes. 3 3 belongs to R. Yes. And 4 4 belongs to R. So therefore R is reflexive relation. Okay. So therefore R is reflexive relation. So R is reflexive relation option A and option B and option D. Okay. Option C is not valid because not reflexive relation. So only three option. Okay. A, B and D. So next symmetric relation. Okay. So symmetric relation means AB belongs to R, so implies BA belongs to R. Okay. So first of all check first pair order pair 1 2 belongs to R. Okay. But 2 1 does not belongs to R. So therefore R is not symmetric relation. Okay. So R is not symmetric relation. So option only B R is reflexive okay and transitive but not symmetric relation. So okay. And next so only option B remain. So option B is correct answer. But check here suppose AB belongs to R and BC belongs to R. So implies AC belongs to R. Okay. So here first 1 2 2 2. Okay. So 2 2 so therefore always true. Okay. So therefore R is transitive relation. All pair AB belongs to R and BC belongs to R, so implies AC belongs to R. So therefore, R is transitive relation. Okay, so correct answer is option B. Correct answer is option B. Okay, here R is reflexive and transitive but not symmetric relation. You are interested to contact our Param Guru Pathshala English Medium School, Sarsa. Thank you very much.